So for today's lesson, we are going over functions. So for our warm-up, it says determine whether the following are functions or not, and it wants us to give a reason. So for number 1 here, we need to remember what a function is. Every input has one and only one output. So if I look at all my inputs, which are on the left side, -8 has one output. So far, so good. -1 has one output. 0 has one output. But I notice that 15 has two outputs. So this is not a function. And the reason is 15 has two outputs. Now if we go ahead and look at number 2, we can trace it again. My input of -3 has one output. My input of -2, well, it has two outputs, so this is not a function. My reason, -2 has two outputs. So, if we move on, our notes go over functions and relationships. Zoom back out. Like I said in the warm-up, a function is a special type of relationship where every input has one and only one output. Now, that was given us in a mapping, which down below says is a way to represent a relationship that shows how elements are paired. Now, if we are given it as a graph or graph out our functions, we could use the vertical line test, which is when you draw vertical lines up and down through any part of a graph of the relation, and the line can only cross the graph of the relation once. If it intersects more than one place, then the graph is not a function. So if I look down at my practice problems, if I draw vertical lines, right there I only hit one spot. I only hit one spot. One spot, one spot, one spot, one spot, one spot. So this right here, yes, is a function. Every input has one output. If we look at the next one, is this graph a function or not? I start my vertical lines. And I can see, whoop, right there, I'm hitting two spots. If I do another one, a vertical line at x is equal to 3, up, I'm hitting two spots. So, not a function. It fails the vertical line test. Now, remember, function notation. It is just a way in which a function can be represented using symbols and signs. If we have like y equals mx plus b, instead of y, we have f of x, which is denoted like this. F and then x is in parentheses instead of our y. So it's easy to convert from linear to function notation, like it says right here. And it helps us if we want to determine certain input values. So, like it says here, steps to evaluating a function given a specific value. And here is my example. What is f of -3 when f of x is equal to -5x plus 7? So my first step is to replace the variables with the given value. So I replaced -3 in for x. And then I'm using PEMDAS to evaluate. I know I need to do -5 times -3 to get positive 15, and then I bring down that plus 7. Then I add 15 plus 7 to get 22. So f of -3 is equal to 22, and then I can check my solution to make sure it is correct. Now going back and forth between function notation and linear equations, remember we just changed the y with f of x. So this should say f of x, so I apologize, but if I write this in for my equation, y is equal to 4x squared. I'm going to zoom in. I would just change it. F of x is equal to 4x squared. Number 3, y is equal to 22x minus 5. F of x is equal to 22x minus 5. And finally, the last one, y is equal to x cubed plus 4x squared minus 6. Again, I replace y with f of x and rewrite the equation. And that's function notation. And then we can practice solving for specific values. So if f of x is equal to 3x minus 4, we want to know what f of -2 is, f of 5, and f of 10. So for f of -2, I'm replacing my x with -2 and solving. 3 times -2 is a -6, and I bring down that minus 4. -6 minus 4 is equal to a -10. So that would be my solution when f is -2. For f of 5, now I'm just going to replace x with 5. So I'm going to have 3 times 5 minus 4. And do PEMDAS. 3 times 5 is 15. Minus 4 is equal to 11. And finally, f of 10. Again, I replace x with 10 this time. So I have 3 times 10 minus 4. 3 times 10 is 30. And 30 minus 4 is 26. The next section is we're going to go over perpendicular lines. So we're going to be looking at perpendicular lines which have negative reciprocal slopes of each other, and parallel lines have the same slope. So remember that a negative reciprocal of a number is that when you flip the sign and flip the fraction. So for example, the negative reciprocal of positive 5 is -1/5. Our sign changed from positive to negative and our fraction flipped. Another example, a negative reciprocal of -3/8 would be positive 8/3. Our sign changed and the fraction flipped. So if we go through these following examples, number 1, the negative reciprocal of -5/2, it's going to be positive 2/5. My sign changed and my fraction flipped. The negative reciprocal of 7/8 would be -8/7. My sign changed, my fraction flipped. For number 3, we want to find the negative reciprocal of -10. Remember, any whole number can be written as a fraction if you place it over 1. So the negative reciprocal of -10 would be positive 1/10. And lastly, the negative reciprocal of positive 91 would be -1/91. So, for the following 4 questions, we want to write an equation of a line that would be, this should say perpendicular. Perpendicular to the line. So, here's our equation. Y is equal to negative 5/2 x minus 2. I need to switch my slope to be the negative reciprocal of negative 5/2. So doing so would be positive 2/5. I'm going to keep x, and then for your y-intercept, it can be anything. So I'm going to do plus 3. But the slope is what actually matters. For the next question, y is equal to negative x minus 5. Don't get confused, negative x really has an invisible 1 in front of it. So if I rewrite it, it would be the same thing as y is equal to negative 1 over 1x minus 5. So if I write an equation that's perpendicular to it, my slope needs to become the negative reciprocal of negative 1, which would just be positive 1. I keep my x, and then for my y-intercept, again, it could be anything, so I'm going to do plus 5. For the next question, again, we're doing perpendicular. Y is equal to 1/2 x plus 5. The negative reciprocal of 1/2 would be negative 2 over 1 x, and then again, my y-intercept, I'm just going to put plus 3, but it could be any number added or subtracted. And lastly, y is equal to negative 1/3 x minus 4. I need the negative reciprocal of negative 1/3, which would be positive 3 over 1. I keep my x, and my y-intercept I'm going to make negative 6. For the next section, we are looking at the line of best fit. So it's a straight line that best represents the data on a scatter plot. So it may pass through some of the points, none of the points, or all of the points, but we should try to put it in the middle of the data. So we should have as many points above it as below it. So if I look here at my options, from all of these to look at, I have a y-intercept of negative 2, which I feel like is a pretty good bet here. If I drew in a line of best fit, it would be approximately there. So I need to look. I can see that my trend is going down, so I know that my slope needs to be negative, which means A and C are out of the question. And from here, I want to find my slope. Is it going to be negative 3/5 or negative 5/3? So if we find a couple of good points and draw the lines, I would say from here to our y-intercept, I'm going down 1, 2, 3, 4, 5, and to the right 1, 2, 3, 4. That's about 4, which would be closest to D. Because we could have also interpreted it about there, which would give us that 3. For our next one, I can look, we have a positive trend line, so I know that my slope needs to be positive, which means C and D are out of the question. If I go ahead and try and do my line of best fit, I want to go through the middle of my data, which would be approximately there. And to find the slope, if I do 2 perfect points, I can look right here. I'm moving up 2 and to the right 1, which would make my slope 2, meaning A is the correct answer. And for the next question, 3, I can see this one's a little bit trickier, but if I draw my line of best fit, there is a positive correlation. So I know it needs to have a positive slope, which would cross out B and D. And if I look at perfect points, I can see I'm going up 1 and to the right 4, which means my slope would be 1/4, which gives us C. And that's it for today's review.